Hey everyone. So we spent a little bit of time last week talking about impact analysis, which is a fairly important part of software engineering if you're looking to sort of get a job as a software engineer and kind of keep it. So the rest of the week was really focused on helping people through some issues with group projects and making sure everybody was kind of set to start working on those group projects remotely in a much more broad sense of the term than we were before. So what we want to do this week is look at software licensing, which is a sort of general concept that we've discussed in a little bit of detail before in the class, particularly for those students who feel like they want to be able to market their group project after they've completed it. But we've also discussed it in terms of how do you actually sell software after you have created it. So today what I want to do is kind of wrap all of that stuff up into one lecture that kind of presents both sides of software licensing, what it means in terms of potentially your future job, but also what it means in terms of terminology that you might have seen before, but could have been a little bit unfamiliar. So we have previously discussed the main differences between what I'm referring to in this class as software consultancies and the sort of traditional kind of software organization. And so consultancies really focus on services, while traditional software organizations kind of focus on products. And like we said earlier in the semester, all of these terms that we use in software engineering are kind of gray, right? That does not mean that all software consultancies cannot have products and that traditional software organizations do not have products. It simply means that they have a specific focus, and while a consultancy might provide products, its main goal is to provide sort of one-off projects or services. So each of these ideas, particularly products, can be sold in any number of ways, but the options really boil down to two main ones. The first of these is continuous usage, which means that you buy the piece of software or you incur the service, you pay upfront, and then you can continue to use that license or that service or that product as long as you want off of that initial payment. The second option is a recurring fee model. So this is much more familiar to something like Hulu or Netflix, where you have a service, you have a product associated with that service, and what you're doing is you're paying month over month for access to that product. So if you pay for this month of Netflix, you can go on and you can watch however many movies or shows you want. But if you stop paying that license fee, you're going to lose access. And even though you may have access to the application itself, the Netflix application, the application is not going to actually allow you to use it. You can see the pretty splash screen, but you're not necessarily going to be able to see a movie without paying. So software licenses are the concept that is underneath all of this. So software licensing is basically the process by which a client or an end user purchases a piece of software or a service that is implemented by that piece of software and effectively uses it, right? So you buy access to Netflix and all of the movies that are hosted therein, or you buy Microsoft Word and you can use Microsoft Word to create as many Word documents as you want. And the way that you pay for Microsoft Word and the way that you pay for Netflix is traditionally very different. But now with things like Office 365, those license patterns and revenue streams for those respective companies are kind of converging basically to the same thing. So the idea behind all of this is, let's say that 20 years ago, you wanted to go and buy something like Microsoft Word. You would go to somewhere like Walmart or Office Depot or somewhere else, and you would physically locate a box that said Microsoft Word on it, and you would buy that thing. Inside of the box there would be a CD. The CD would be inside of a CD sleeve, and the CD sleeve would typically have a license key that you would use to register the product. so that Microsoft understood that the specific CD that you just purchased is linked to the installation of Microsoft Word that you just put on your machine, and they can effectively have traceability between your payment and the specific installation or implementation of Microsoft Word that you purchased. Now, what happens is instead of going to a store and actually getting a physical piece of media, what you typically do is you download the software, you download the code that represents that software, be it in binary form typically. You get a license key as part of that process, so it gets emailed to you, it gets texted to you, whatever. Then you go through the exact same registration process where you provide that key, which then links your payment to the specific implementation or installation of that application. And then the vendor that actually provided you that application can always understand that linking. So they know this GUID or this unique identifier maps back to Chris Mills, for example, and this is his credit card information that we have on file, et cetera, et cetera. So that is a pretty rudimentary concept of paying for a good or a service, right? So this gives us the idea of buying a unit of software. So we have a one-to-one mapping in some senses of your download and your product key, but there are tons of questions that arise out of this. So what happens in the situation where you download Microsoft Office, but you have 97 computers in your company and you want to install that specific implementation of Microsoft Office onto each of those 97 machines? That is a question that will be answered differently by Microsoft versus Adobe versus whoever the software vendor is that you're buying software from. Additionally, what happens if you download the code, it goes into your downloads folder, and then you delete everything in your downloads folder trying to free up space, and then oops, the download is lost, and now you don't necessarily have the binaries that you originally paid for that potentially are linked to your license key. There are tons of companies who deeply, deeply care about the traceability link between the actual binary files and the license key. For example, Kofax cares deeply about this kind of thing. Other companies don't care at all, right? So the answer to this question, again, is going to be dependent on who you're actually buying software from. Another question that arises a whole lot, particularly in older software where you have to have a physical medium, is if I buy Adobe off the shelf and I have a PDF reader, and suddenly the PDF reader does not work for a certain size PDF, for example, do I now have to buy a new version of Adobe Acrobat Reader in order to read that PDF? What happens if there is a security issue in that original implementation of the software? Do I have to buy a new version? Or what is the mechanism by which the software company is actually going to give me remediation, right? How are they going to ship me a change? And how am I going to acquire it? Am I going to have to be in a position to purchase it, or is it going to be just part of our original agreement? So license terms themselves come in many, many, many forms. And so these are basically just 4 examples. We have things like terms of use, terms of service. We have broader things like maintenance agreements, which are typically for much larger software purchases. And we also have things like master services agreements that kind of sit on top of license agreements or other license terms, which allow a software company to offer services in addition to a product. So if you wanted to engage with Microsoft to build hyper-specific macros for your custom implementation of Microsoft Office, the master services agreement would dictate how they can bill for those services, what those services look like, and what components of those services, if any, are actually covered by your original license that you purchased in order to just use Office to begin with. So all of these license terms, the intent of them is to actually answer those questions that we just rose, right? So what you want is you want license terms to answer as concretely as many of these questions as physically possible about specific applications or products for each company. So The terms of use for a specific piece of Apple software can be different from another piece of Apple software, even though they're created by the same company. Likewise, Apple can have much different license terms than Microsoft, can have much different license terms than Google, so on and so forth. So where you get into problems is when these license terms are insufficient. So when a person can actually raise a question that is a legally binding question in some ways that your license terms are insufficient to answer. When that happens, then you have a whole bunch of legal issues where you kind of have to, in a lot of ways, negotiate the answer to that question. This is largely what makes things like terms of service and things like terms of use so obnoxiously long. What a company wants to do is outline as concretely and as precisely as possible all of the different things that you can and cannot do with their application in order to reduce the risk that they bear that you're doing something crazy or you're trying to reduce revenue that they would otherwise get with a more restrictive license. So we might ask a question like, do I have to pay for multiple licenses? So going back to our previous example, do I have to actually purchase 97 licenses in order to install this piece of software onto 97 different machines? And the answer is, if the terms of use say you do, then yes, you absolutely do. If the terms of service say, or the terms of use say, you can have the installation on up to 3 machines, which is very common, or up to 5 machines, which is also common, you can purchase fewer licenses. But even if the software allows you to install on 100 machines, and you are only licensed for 3, then that is a violation of these terms, which is a legally binding contract, and bears with it some legal ramifications for the company who is using effectively unlicensed business software. So in Tallahassee, if anybody has ever driven up Capitol Circle to the flyover to on I-10, there is a billboard, or there used to be a billboard right there at the flyover that was a hotline that you could call to report businesses that are using unlicensed software. That billboard is effectively implementing the legal consequences of doing things like breaking license terms, even though you physically can. So it is not the onus of the software vendor, the software firms, to restrict you necessarily. The onus is on you to actually abide by the terms of use that you agree to by purchasing and installing the piece of software. We go all the way back to this idea of what is a consultancy and what is a one-off project versus what is a product. And we previously talked about how project proposals themselves can be extremely long. And as we start adding things like technical specifications or use case diagrams and those kinds of things, we effectively arrive at a very tight definition of what the software company is going to be doing and the expectations of the client for paying for that service or paying for that product. And at the end of the day, what we come up with is a very, very large contractually binding agreement that the software firm is going to provide a product or service of this particular size and shape, and the client is thereby going to pay for it. And so once they have mutually executed this agreement, and once the client has signed off on user acceptance testing as specified in that document, they are required to pay the software firm, and the software firm effectively just becomes a general creditor to that client. So for software products, though, these proposals are obviously going to be far less formal. And so if we're developing a product, what we've talked about is the client for that product is typically an internal entity. So if I am at Microsoft and I'm trying to create Microsoft Word, or if I'm at Google and I'm trying to create a brand new product, there's going to be someone in the company that is responsible for that product. It's going to be a product manager or a team of managers that kind of have the vision and what that product is supposed to be doing. But you're not necessarily going to have a legally binding contract between a development team and another internal team that is driving that project. So It's really important to think about software licensing in terms of the parties of that license. So if you're talking about a project proposal for something like services or something like a one-off product, those parties are typically the software engineering firms, so the developers that are doing the work, the project managers that are helping those developers implement the code, and that external client. So the bank that is trying to use the system that the software developers are developing. For products, the parties are usually the software engineering firm, so Microsoft or Google or whoever, and the actual end user who very often has essentially no agency on what the product is or how it is developed in the future. So while you can say that you want this hyper-specific button to be added to the ribbon on Microsoft Word, and many companies provide you the ability to offer feedback, they don't necessarily have to do anything with that feedback, and they can effectively throw it in the trash. So these types of clients are drastically different. The client in the first sense is a client who can change that legally binding contract to essentially force the software vendor to do a specific thing. An end user in the product sense cannot often do that. It's kind of an unusual circumstance where you can legally require a software vendor to do a specific thing for a product. So at the end of the day, the purpose of all of this is to reduce a software company's risk associated with a user, be it an end user or the client that you're trying to create a one-off project for, misusing that application. And so we see these things commonly on stuff like Facebook or Twitter, where they have specific terms of service that keep you from doing things like radicalize other individuals. So there are components of the terms of service for both Twitter and Facebook and YouTube that keep you from promoting hate speech, et cetera, et cetera. So obviously, if they did not have those terms of service, somebody could go in and do some crazy radicalization of a subsect of people, and then it is legally unclear who would be liable for that, what liability the software vendor has in terms of providing a platform that was used for a nefarious purpose. Another example would be terms of use that distances the software vendor, so the creator of a PDF editor, from a user that uses that PDF editor to commit fraud. So if you are creating a completely non-nefarious piece of software, you always have to be aware that there are users that will attempt to use your service or your product as a platform to do something illegal. And while obviously the user would be held liable for that illegal activity, in a lot of cases it's unclear what liability the software company has for providing the tools with which the user was able to perform illegal activity. Another less legal and more practical consideration would be terms of use that prohibit something like a very large corporation from installing a single software license, which may cost $10, on 50,000 employee machines. So instead of getting $500,000 in this case, you would actually only get $10, which is obviously a much lower amount of revenue, and that has impact on your ability to function as a software organization. So what you want is to very clearly outline those kinds of things in terms of use or in terms of service to effectively protect your organization from nefarious uses. Again, master services agreements are really around additional services that a company can do on top of providing a product typically. And so what these can do is something like a large company could otherwise use the idea that there's a lack of functionality as leverage in a negotiation against a software vendor, but with specific terms inside of a master services agreement, you can actually dictate what is a customization or what is an addition to your product, and legally sort of define those activities so that if this is used against you as leverage, you can always go back to the master services agreement and say that the client agreed for you to provide those services at XYZ rate per hour, or at some prearranged fixed fee, and you can always recoup money for that effort, even if you are required in some sense, be it a business relationship or a legal reason, you can still recoup some cash for that effort. So up to this point, what we've really talked about is this kind of academic idea, right? You can always write on a piece of paper some very restrictive covenants, but if you can't enforce them, it doesn't actually really matter. And so you see this kind of thing in contracts all over the place. If you buy a house in a neighborhood that has a very restrictive set of covenants for the HOA, if the HOA doesn't actually enforce those covenants, it could be much less restrictive than even a slightly restricted HOA that does enforce those covenants. So three very popular ways that software companies can enforce license terms. The first one is called automatic registration. So basically this goes back to the idea that we were previously talking about, where you have a series of unique numbers. You have a registry of those unique numbers. Once a user links a specific application or a specific install to one of those numbers, you can keep track of how many times it's been installed, and you can keep the user from installing too many times. So instead of having to have a billboard on Capitol Circle and begging people to seek out and identify businesses that are using software that is unlicensed, you can effectively physically restrict or technologically restrict the company from violating those terms. If your terms say that the software can only be installed up to 3 times, you have a counter on the unique identifier. Every time it installs, it sends a signal to the server and says, hey, increment the counter. As soon as the counter exceeds 3, then boom, make sure that the install fails. Obviously, this requires Wi-Fi connection. You can see all sorts of issues around the details, but it's kind of a way to do some due diligence around forcing people who have bought a license to play by the rules. A much more familiar version of this is also called digital rights management. So anybody who has played video games kind of understands this concept. You have proprietary hardware in a lot of cases. That proprietary hardware only recognizes specific types of media or specific types of files. And if a person is able to replicate that code or replicate that executable, they also have to be able to replicate a very difficult to replicate piece of code or watermark or something that is required in order for that proprietary hardware to run the piece of software. So what this typically does is deters piracy, that kind of thing, but it's all the same concept around license terms, right? The idea is you don't want people to be able to use a piece of software that is unlicensed. That is, you don't want them to have the benefit of having code without paying you for the code that you spent effort and time and resources to build. The last one that we'll talk about is call home auditing. This is for much larger implementations. So think about something like a banking system that is installed on tens of thousands or maybe even just thousands of workstations around the world. What you want is you want to be able to automate the process of providing new licenses so that you're not necessarily blocking usage, but you're getting paid for each license that is active. So what will typically happen is periodically there will be some call home on that application that says, hey, dear server, I am installation number 115, and they will be registered to the same client. And then there are statistics that help the software company understand how to assess a bill or send an invoice to the user or to the client. So that software vendor will say, okay, last year you had 97 users, this year you have 150, so your bill is going up by XYZ%, and that percentage would typically be presented in the license agreement that you agreed to when you first purchased the system. So all of these things you can see have a lot of commonalities. They have a lot of the same pitfalls. But it gives you kind of an idea of the technological ways that software companies can try to enforce their own license terms to protect themselves from the risk of people sort of not playing by the rules. So up to this point in the lecture, what we've really talked about is the connection between software licensing and the software company's ability to bill. But clearly not every piece of software is paid to use. And I'll take a sidetrack here. There are things like Facebook, for example, where you effectively have terms of service and you agree to those terms of service by logging in and making an account. You don't necessarily ever have to pay for Facebook in money. You are paying for Facebook in a lot of ways through releasing data about yourself or about your usage patterns on the site, et cetera, et cetera. What I'm talking about here is pay-to-use software in the aggregate sense. So even though you don't pay for Facebook with money, you are paying with something else, some other currency. What we want to talk about here is truly software that you're not paying anything for. These things typically come in the shape of libraries that you can use to implement UI components, or drivers that you can use to make sure that your monitor works, or drivers that you use to make sure that your application can connect to something like MongoDB or some other database platform. And so open source software is often free to use. But it also has license terms that dictate how that software can be utilized and the ramifications of actually taking that free-to-use software and incorporating it into your application. And so here, I want to back up just a little bit and soften that initial verbiage. Open source software is often free to use, but the idea is that the source code of the software is available. You can actually go and download and look and modify that code. What we're saying here is that there are tons of components that you don't necessarily have to pay for that are open source. But if you incorporate that open source component into your actual application, it can have long-reaching implications to the open source nature or even the pay-to-use nature of the application that you're trying to build. So the kind of warning that I'll put here is that software licensing, particularly around these open source integration licenses, is a very, 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 very technical, very deep thing that has a lot to do with law and not a lot to do with actual technical implementations. The content of this video, the content of the slides is not necessarily legal advice, and it shouldn't be taken as such. If you have questions about specific licenses and your specific application, you should definitely seek legal advice and not the advice of a software engineer. This is well outside the toolbox of a standard software engineer, but it's something that you need to be aware of as a software engineer so that you don't necessarily kind of hitch your company's code to the wrong horse, if that makes sense. So the Open Source Initiative is a group that provides both standards and legal definitions for what open source software is, and provides a background and verification for very common licenses that are used to actually provide a legal framework by which that open source software is defined, and the rules that apply to each piece of software. This is their website. And if you go onto their website and you spend maybe 5 or 6 minutes snooping around, you will very quickly become aware that the water is very deep, like I said, and a lot of these licenses are not very understandable, primarily because they are not written in sort of standard English as you would probably expect from reading terms of service at something like Apple. So as you look at these things, you will see that some of them are very short, but some of them are very, very long, and you might recognize a lot of the same sort of verbiage or a lot of the same clauses from something like the Apple terms of service that you sort of nod and agree to every time you get an update on your phone, or the exact same thing goes for Android. So these things are long. The reason they're long is they have to provide quote clarity, end quote, for all of these different scenarios that may never apply to you at all. But there is some concern in general that because of their length, it's very, very easy to hide things in them that people kind of blanketly accept. And this definitely affects software organizations in that a lot of these agreements to use open source software can have negative side effects, and you may not be aware of them because the license is so long that it is sort of incomprehensible or incomprehensible to a standard software engineer. So on one end of the type of licenses that you might see is something like the MIT license. So this is widely believed to be one of the more non-restrictive licenses. And what it does is it allows unfettered access to the associated piece of software. So you can actually go in and you can look at the code, you can repackage the code, you can modify the code. You can actually take something from with an MIT license, you can slap a different name on it, and you can try to sell it. And that's entirely legal in this framework. The only thing that you're required to do is you're required to post the MIT license verbiage prominently somewhere on the application. So typically you would have a dialog box or something that somebody has to accept. And the caveat is if you just repackaged an MIT licensed piece of software and you tried to sell it, you have to make it clear that somebody could go elsewhere and get it for free. So it would be very unlikely that a person would pay you for something that is otherwise free if they just went to a different website or they went to a different vendor. So this is kind of the non-restrictive example or exemplar case that I want to talk about. And if you're using a software component that is licensed under the MIT license, you can largely do whatever you want to with it as long as you are clear with the user of your software that your software contains some component of code that is licensed under the MIT license. And the nice thing about the MIT license is that it's actually short enough that you can take a screenshot of it and you can put it on a PowerPoint slide. And so what I've done here is I have underlined the sort of pivotal part of the license. And so it says that this license grants the user the ability to deal in the software without restriction, including without limitation, the rights to use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software, and to permit persons to whom the software is furnished to do so, subject to the condition that, and you see it underneath, you provide prominent notice to all people that some component of the derived piece of software is licensed under this agreement. So this leads us to some commonly kind of confused terminology that I want to try to make clear. And you can see from several slides ago, I myself even kind of confused some of these terms. So Open source software, what that means is that the source itself is actually freely available and it's distributed typically online. So you can acquire that source code, you can compile it, and within some number of minutes, you can have a running copy of the software. You can then use that code to modify the piece of software, recompile it, and now suddenly you have your own orange version of the executable, etc., etc. Closed sourced means that the source code itself is a closely guarded secret. And so you can imagine the difference here is something like going and getting a recipe off the internet for a particular meal versus trying to steal the exact recipe for Kentucky Fried Chicken. These are drastically different things, and while you might be able to build your own version of Microsoft Word, the actual source code for Microsoft Word is a closely guarded thing, and in order to gain access to it, you either have to work for Microsoft or you would have to purchase access to that source code from Microsoft at an extremely high rate. So even though you can acquire compiled closed source material, you can even acquire some of that material with a free license. So something like Notepad++. You do not necessarily have to pay in order to gain access to the application, but that doesn't necessarily mean that you have access to the source code. Now, Notepad++ might actually be open source, I'm not entirely sure, but every time I've gone to use it, I haven't actually used the source code. I've actually just downloaded the executable, run it, and went along with my life. Contrast this to pay-to-use software, which is exactly what you would think, right? This is software that you pay to use, be it open source or closed source. You have to purchase a license and you have to abide by those license terms in order to be compliant with the company that you're trying to purchase the software or the service from. So, combining all of these things together, it is in fact possible to have open sourced pay-to-use software. What this means is you have access to modify the code, but in order to have access to the code, you have to pay for it. So one of the examples of this is Enterprise Red Hat Linux. You can actually modify the code, but the enterprise license does actually cost something. It isn't free to acquire. So this brings us to the difference between open source code versus customizable code. And so we talked about one of the very largest components of the software services industry being focused on taking frameworks and actually molding those frameworks into applications that clients or companies or corporations need in order to run their business. As an example, there are tons of corporations using things like Salesforce.com or SAP, and all of these companies, while they are using the same framework, if you went in a sort of day in the life of one of their employees and you looked at the application that is created with one of these frameworks, they would all look drastically different. So there are law firms that use SAP, there are very large manufacturing companies that use SAP, there are chemical companies and all sorts of different industries use the framework, but they don't necessarily use the same application suite, they don't necessarily use the framework in the same kind of way. So what they do is they pay a company to actually mold that framework or build applications out of components of that framework. And so the easiest sort of metaphor that I have for this is something like Lego blocks, right? So when you go and you ask for access to Force.com, which is one sort of the framework that Salesforce is built on, you get all of these different components. And so you can think of SWT UI components for Java as an example. You can use these things to build a million different things. You can build cars and spaceships and hospitals and hotels and buildings out of Legos, but you can't necessarily take a 6-peg block and somehow make it into a 4-peg block, or somehow change it from being a rectangle to a star-shaped block etc., etc. You don't necessarily have access to the source code of the components, which makes it a closed source framework. But you do have access to take that closed source software and create an application out of it. And those are the primary differences between something like an open sourced project and a customizable framework that is closed source that allows you to build applications. So on the other end of the continuum of restrictiveness in terms of open source licenses, we have something like the GPU GNL license. And so if we take a look at this link in the PowerPoint slide, it will take you to a website that has a very, very, very long set of license terms, and it will be very obvious that it is much more restrictive and much more rigid than the license the license text that the MIT license has. That is effectively carte blanche. You can do whatever you kind of want to with this piece of software. Interestingly, this particular license is what's referred to as a copyleft license, which means that any derivative application, so any application that uses a component that is under the GPU GNL license, has to use itself an equivalent license. And I put equivalent in quotes because legal equivalence is a thing that's far above my pay grade. But suffice it to say that if you incorporate a third-party component under this license into your closed source application, congratulations, you've just open sourced your closed source application because GPU GNL is an open source license. So it is not possible to have a closed source application that uses GPU GNL components because that closed source application would be required to use an equivalent license to GPU GNL, which is open source. And this is the crux of the situation that I've been explaining to some of the groups that are interested in marketing their group project after the semester. If you're using a component that is under GPU GNL or another copyleft license, what that means is you can still charge license fees for using the application, but you have to provide the source code, and your ability to acquire payment for the license is dependent on the license terms that are set out in that copyleft license. So if the copyleft license says that you can't use this piece of software or third-party component inside of a corporate or a commercial piece of software, then you can't have any payment received for your derivative piece of software. So this can become a very large issue for software companies who are looking for code to reuse. So this leads us to something called open source license compatibility. So very large software companies are extremely interested in license compatibility because misunderstandings of license compatibility can create very large problems that have very large consequences in terms of revenue, but also in terms of your legal standing or your ability to actually operate as a corporation, something that is for profit. So we all know that reuse is one of the cornerstones of software development, and if you're trying to build every component of your group project from first principles, sort of line by line, you are doing yourself a disservice. We have over decades, if not much longer than that, understood common algorithms. We have created common protocols, etc., to make software development easier. And so if you are careful and you reuse code that's under a fairly unrestricted license, this code reuse makes your life easier. It makes it very possible to build very large pieces of software with a small team and with very little time. However, if you use code that is under a restrictive license, you can accidentally imply or impose those restrictive covenants or those rules onto your associated code. And so what happens is good firms, large firms that are very aware of this kind of problem, like the Googles and the Microsofts of the world, will have periodic audits of all of the components that they are using. And what that audit will do is it will try to uncover any of these compatibility issues. And so they will say, oh man, we're using a grid control in this one specific application, and that grid control is under a GNU GPL license, and so because of that, we can't actually use that grid control. What we need to do is either find a new one that is under a much less restrictive set of license terms, or we need to build our own. And so this goes all the way back to our buy it or build it conversation that we had during the design and the architecture lecture. But you have that remediation step. If you can identify that there are compatibility issues, you can always go and remediate them. The problem is once your code is distributed, it is too late to remediate. Somebody has already paid you potentially for a piece of software that you can't legally be paid to sell or to provide. And so the trick here is to catch compatibility issues prior to going to market with license compatibility conflicts, so that you are in good legal standing to actually continue to operate and provide that service or provide that product, and actually create revenue that then can be used to pay your developers, pay for overhead, and continue to operate. Software license compatibility is extremely important in order to not only sort of continue to operate as a company, but also operate as an above board company. There are tons of PR issues that you can run into if you are untowardly using open source software, and so you kind of want to always be mindful of the third-party components that you are putting into your code, and how that impacts your ability to either gain revenue from that code, or keep the code and the algorithms in that code closed source, and sort of proprietary information that is visible only to your organization. So that is a very high-level overview of software licensing, both from the revenue side, where you are trying to sell licenses to a client, but also from the expenses side, where you're trying to incorporate other pieces of software into your derivative software, and sort of protect yourself not only from users misusing your code, but also keeping yourself from misusing somebody else's code that could have a negative impact on your organization either direction. So please, if you have questions, if you have comments, concerns, please feel free to email me any of those, and I will be happy to respond. Next week, we will also try to talk about some more topics, but one of the main things that we need to focus on for the rest of the course is ensuring that everybody's iteration 3 submission is really, really strong. Also, if you have any questions at all about the plight of your group, or what you're doing in order to wrap up iteration 3, please let me know. I'm also happy to answer those questions as well. Thank you very much, and I hope you have a great day.